A speed-loving friend just gave me 2 new spark plugs. Sounds unrelated to antennas. But today we'll turn them into part of a DIY project. But what if these 2 spark plugs are paired with a paintbrush? We'll see if this combination can open up a more interesting way to build an antenna. Now I'll grab a screwdriver and start with just a few simple moves. The goal isn't to take the whole brush apart, but simply to extract the wooden handle inside. That wooden handle is the interesting piece here. It's sturdy, easy to work with, and most importantly, it can serve as a central support to hold the 2 spark plugs together. If we leave the brush as it is, it just looks like half-finished painting gear. But once the handle is removed, it becomes a perfect backbone for a compact DIY project. Quite often, in ordinary objects, the part we think is secondary turns out to be exactly what we need. This wooden handle is a perfect example of that. In this step, I'll drill 2 holes at the top of the wooden handle to secure the spark plugs. Conveniently, the drill bit matches the spark plug threads, so once screwed in, they hold firmly without wobbling. A quick tip: place a wooden board underneath. This protects the drill bit and makes the whole process safer and cleaner. Now I'll attach the 2 spark plugs into the holes drilled at the top of the wooden handle. By slowly twisting them in, the threads lock firmly without needing glue or extra screws. Once both are secured, they stand upright, parallel to each other, as if the handle had been made specifically for them. At this point, the wooden handle no longer looks like a paintbrush. It's transformed into a solid frame, ready to serve as the base for this DIY antenna project. You probably didn't expect this, but I'm going to take this tiny SIM card and repurpose it as a miniature circuit board for connecting the wires. To keep it stable, I'll secure the SIM flat against the wooden handle, almost like attaching a small control panel onto the frame of the project. In this case, liquid glue is the most reasonable choice. It sticks well and keeps the SIM flat and neat on the surface. This step sets up a clean way to manage all the wiring for the antenna. In my hand is a small jar of soldering flux. This flux is usually used in electronic soldering, making the metal stick better and improving conductivity. Now I'll spread a thin layer across the surface of the SIM. Nothing excessive, just enough to ensure stable contact when we attach the wires later. After spreading a thin layer of flux across the SIM surface, I'll take out the handheld soldering tool and begin heating the tip of the aluminum wire. Once the temperature rises high enough, the aluminum melts down into tiny shimmering droplets. I'll carefully place each droplet at the 4 corners of the SIM, almost like beads of water resting on glass. These 4 points will not only anchor the aluminum wires in place, but also create solid conductive joints. As a result, the SIM now looks like a miniature circuit board with 4 neat connection pads, ready for the next wires to be attached. These are 2 wires I prepared in advance. Since the exposed core was a bit too long, I trimmed it down, leaving just enough to solder onto the SIM. Now I'll dip the 2 exposed copper ends of the wires into the soldering flux. This thin coating cleans the copper surface and allows the solder to stick more firmly when we connect it to the SIM. Now I'll use a soldering iron to melt the tip of the aluminum wire and press it against the copper core that's been coated with flux. At this moment, the flux does its job. It cleans the copper surface and allows the molten metal to bond more easily. As the heat builds up, the aluminum softens, spreads out, and wraps around the copper, forming a tidy solder joint. This way, the aluminum and copper not only stick firmly, but also ensure stable electrical conductivity. Next, I'll position the prepared wire right onto the aluminum drop on the surface of the SIM. These aluminum drops work like tiny anchor points, already placed to secure the wire firmly. As the soldering iron touches down, the heat softens the aluminum again, letting it wrap around the copper core. I'll hold it steady for a few seconds so the heat spreads evenly, allowing the aluminum and copper to bond tightly without loosening under stress. The result is a neat, shiny connection on the SIM surface that stays stable and conducts electricity reliably for the next steps. Now I'll reuse a cable I already had at home, 100 centimeters long. Instead of going out to buy a new one, I measure halfway, about 50 centimeters, close to 20 inches, and carefully cut it. This way, we end up with 2 equal cable pieces, saving material while making it easier to connect and arrange neatly in the project. Now, grab a utility knife and follow the steps you see on the screen. Of course, I'm not removing the entire outer insulation of the 2 TV antenna cables. Instead, I'm stripping away the outer layer while keeping part of the inner insulation intact. That's the dielectric layer of the antenna cable. This dielectric section is important because it protects the core and helps the signal travel more consistently. When it comes to short cable pieces, most people don't realize they actually have a bit of history behind them. Back in the early 19th century, when telegraph lines were still new, workers often had to join short pieces of wire together to extend communication lines. There was even a story of a massive storm cutting the lines, and telegraph workers had to salvage every short leftover piece, patching them up just to keep the signal alive. Later, during wartime, short cables became even more valuable. In the trenches, signal operators had to use whatever cable scraps they could find to connect field telephones. Sometimes, a single short cable meant the difference between a message getting through in time or not at all. I've zoomed the camera right in on my hand so you can see every move clearly. I hope you watch closely, because even the smallest detail can decide whether the work turns out right. By following slowly and paying attention to each motion, you'll find it easier to understand and repeat the steps yourself with accuracy. Now I'll dip the 2 shortened exposed copper ends of the antenna wires into the soldering flux. Before officially soldering the 2 shorter copper ends of the TV antenna wires onto the remaining aluminum drops on the SIM card, I like to take a preparatory step that may look unnecessary at first glance, but is actually crucial. I begin by pressing the tip of the soldering tool against the end of the aluminum wire, holding it just long enough for the metal to start melting. Once the aluminum turns liquid, it forms tiny, shiny beads, almost like droplets of mercury moving around. At that exact moment, I quickly touch the exposed copper ends, already coated with flux, against the molten aluminum. This thin aluminum coat works as an intermediary bridge. It doesn't just cover the copper and strip away any remaining oxidation. It also creates an ideal surface for the solder to grip onto later. If you ever wonder why some solder joints look fine at first, but snap off the moment you tug at them, this is the answer. Without this aluminum buffer, the bond is weak, unstable, and prone to breaking. By adding this seemingly small step, we're actually upgrading the entire connection. When the wires are soldered to the SIM, the joint isn't just copper touching solder anymore. It's a fusion of copper, aluminum, and solder, all working together as a stronger composite. The end result is a joint that isn't only durable but also neat and polished, and most importantly, it can withstand real-world stress. Whether it's small vibrations, sudden bumps, or even unexpected pulls, this reinforced joint holds firm. Over time, this detail ensures the whole setup remains stable and reliable, saving you from having to constantly fix or redo the soldering. After soldering the 2 shorter copper ends onto the SIM card, I move on to connecting the longer copper ends. For this step, I make use of the threaded tips of the 2 spark plugs as both anchor points and conductor paths. First, I carefully bend the inner insulation layer, the dielectric of the antenna cable, at a 90-degree angle. So the copper core inside is exposed and directed straight toward the spark plug's cap. Then, I wrap the exposed copper wire tightly around the spark plug's thread, making sure it grips firmly and won't slip off. Once the wrapping is done, I twist the contact end back into position and press it neatly into the spark plug cap. Turn the whole setup into a mechanical and electrical joint that is not only solid, but also looks neat and reliable. I even make use of a simple pen to finish this step. After wrapping the copper core around the spark plug's thread, there's still a little extra wire sticking out. Instead of cutting it off, I take the pen and twist the leftover wire into a neat spiral, turning it into a tiny antenna whisker that looks both quirky and useful. This way, the wire stays neatly shaped, while also giving the whole DIY antenna a touch of eccentric style. To keep things electrically safe, I'm wrapping a few layers of tape around the SIM. The goal is to prevent short circuits when the copper wires touch other metal parts. No need to overdo it, just enough layers to keep everything secure. Now, I'm going to connect the other ends to the TV antenna wire. First, I strip off the outer insulation of the two wire segments to expose the copper cores inside. Handle this step gently to avoid breaking the tiny strands of copper. Once the copper cores are exposed, we're ready to connect them to the antenna wire. In this final step, we complete the connection of the TV antenna wires. One end of the wire will be connected directly to our homemade antenna device. This is a point that receives signals in the air, so it's important to ensure a secure and tight connection. Take a careful look at every detail. The wire should sit properly on the contact point. The copper core fully touches the metal inside, and nothing is twisted or misaligned. A solid connection not only keeps the signal stable, but also prevents static or signal loss when the TV is running. If the wire is loose, the signal can fluctuate, causing flickering images or unclear sound. Taking a little extra time to adjust it properly is well worth it. The other end of the wire will connect to the F connectors, one straight and one 90-degree angle, so it can be plugged directly into the TV. Using both types of connectors gives flexibility when positioning the TV in different spots without bending or twisting the wire too much. Before securing, check each connector carefully. Make sure the copper core fully contact the metal inside the F connector without any misalignment or looseness. Adjust gently if necessary so the wire isn't too tight or too loose, which should affect the signal. Once everything is connected, we have a fully functional homemade antenna ready to test with the TV. This is a result of combining simple steps, soldering, connecting, and bending wires, yet it delivers practical, usable results. Look at this. My TV is currently showing no signal. Now, I'm going around the back, carefully plugging it in, and watching to see if our homemade antenna really works. And what a surprise! The TV instantly picks up the signal. The picture is sharp, the sound is clear, no more static or flickering. I just stood there, smiling from ear to ear. This is a moment when all the effort, soldering each wire, bending the spark plug ends, connecting carefully, finally pays off. You know, DIY is not just about creating a product, it's the whole journey. Trying, failing, fixing, and finally feeling proud when you see it actually work. The joy of making something yourself and seeing it come alive is truly priceless. Do you remember the old days when having a TV antenna was considered extremely valuable? It wasn't just a piece of wire or a simple aluminum rod. Every family cherished their antenna like a small treasure because it decided whether you could watch your favorite shows or not. People often climbed onto rooftops, adjusting it bit by bit to get the best signal. Sometimes, an entire afternoon was spent just trying to catch one clear channel. Those moments, though simple, were full of excitement and little joys shared by the whole family. Nowadays, antennas seem small and simple, but back then they were at the heart of every family's entertainment. When making a DIY antenna, I can't help but feel a touch of nostalgia, like reconnected with those precious memories. The afternoons, the laughter, and the thrill of finally seeing a signal appear on the screen. If you enjoyed this video, don't forget to hit the like button to show your support. And if you want to follow along for more DIY projects, make sure to subscribe so you don't miss simple tips, easy step-by-step instructions, and the little everyday stories behind each creation. Share this video with your friends so they can create and enjoy the satisfaction of DIY just like we did today. Thank you for sticking with me until the end. I hope you learned a few useful tips and felt the joy of doing DIY. See you in the next project, where we'll continue turning ordinary items into incredibly useful and fun devices.